Hello, everyone. Happy to see you joining us today. So today we're going to talk about Java versions and features, right? So without much ado, let's get on to it, I guess. So, oops, briefly about me then. So I've been various things in my life. I guess at some point a QA analyst, manager. Finally ended up being an engineer because that's what I really enjoy doing in my life. And also I'm that old, so I have some scars from the old gang Java code and how that worked. And we'll have some maybe semi-fun stories later down the line. Currently, I'm working as a team lead and resource manager at EPAM. Still doing a lot of coding because I really love that. So that's it about me. I guess we can move on to what are we going to talk about today? And that's, roughly speaking, about Java versions, right? So first we'll cover a bit about Java version naming, why it changed, what happened. What we're not going to cover is everything that came before Java 1.8 because that's a lot of things, and that's, I would say, is considered a Java baseline right now, and not something that you kind of cover as explicit things. We'll still touch a little bit of main features that came with Java 8 and are of, I would say, worthy of highlighting, but not that much, right? Then we'll go one by one from Java 8 to Java 19 and really briefly check on what could possibly land in Java 20. And while we're on that, I have a small challenge for you if you feel like it, right? You can later on type in the chat how much of things you noticed. But basically, there is this one funny improvement in Java, right, related to emojis, right? And the idea is to just try spotting how many times among Java versions beyond 1.8, such an improvement is considered a major change in Java, right? So feel free to keep the count, and we'll ask you at the very end how that went, right? First of all, there's this question, right? Whenever you start a presentation, you have to convince your attendees to why is this important, right? So this is my attempt to kind of convince you of that. Why knowing at least briefly, at least really shallowly, Java feature history is something that is of important to you, right? And the first, again, very, very selfish thing is one of those questions that gets asked in interviews, and that happens a lot. Like I've been in a number of those, and that definitely gets asked, right? Probably not about probably not very deep, but at least know a few that really you love, you like, and just learn more about them so you can have something to talk about, right? Another thing is that knowledge is power, right? And knowing what you have as tools that Java brings to you makes you a better developer. So, feel the power, know it, right? Another thing is perspective, right? So if you are stuck on Java 1.5 and you never really dive into things that later Java versions give you, you just don't know what you're missing, right? So this is also an attempt to kind of give you a taste what you're missing if you're not pushing for the upgrades. And speaking of the pushing for upgrades point, if at some point you land in a project which is stuck with, let's say, Java 8, right, and you really want to upgrade, I hope this might be a sort of a guideline along to help you answer the question of why should we upgrade to Java 8, even though all the, up from Java 8, even though it worked fine for the last 8 years, right? And for the record, 10 years is probably the timeline when all the solutions become quite obsolete and the vendors start thinking of kind of replacing them with something. So this is Java 8 right now. If we talk about earlier Java versions, I'm not even going to go there. You definitely should upgrade, right? So let's move on then. Wait, what happened? Okay, Java naming. There are two worlds basically, right, with Java naming. One is before Java 1.8, also known as Java 8, and I will use that term interchangeably and liberally during this presentation. And that period was characterized by a really slow release cycle. So new Java version came once a 2 year, once 3 years, something like that. And that release cycle was not periodic. It was kind of a bit more feature driven rather than being time boxed. Also, it's characterized by the fact that there was only one vendor who was providing JVM. It was at first Sun Microsystems, later it was Oracle when they bought them. But that's also a thing, right? Starting with Java 8, there's a commitment to do 2 releases per year, right? So every 6 months. There appear more JVM providers, and we'll talk a little bit later about why that happened, right? Uh, so that's kind of like two worlds, right? So before Java 8, before Java 8, it's like Java 1.0, 1.1, 1.2, and through Java 8, right? And after that, it's starting with Java 9, Java 10, etc. Right now, the latest one is Java 19, and I think Java 20 is right now in basically being worked on, right? As I said, really briefly, because I mean Java 1.8 and things that came before that is a huge release. So it's really like probably if you would like to cover those features, it would take a whole section in itself. But really touch briefly on what's happened there. So Java 1.8 was itself a very significant release. 1.7 was also and this is, I would say, what people right now consider a Java, like I would say, baseline of what you should know, right? So if you're learning something with before Java 8, you should probably consider learning something at least on that level, because this is the baseline, right? So what comes with Java 8 is the Lambda functions and functional interfaces, right? And this is where we start going into meat and grinder there. Again, we can do a separate talk about how Lambda functions and functional interfaces work, right? Streams API is also something that comes with Java 8. It's in kind of like not fully fleshed out, and we'll see some of the things that I really missed with the later versions coming over. Date as such got deprecated, and time API was introduced. So you have now local dates, you have time zoned based dates, and it's like a lot of good lessons were learned from third-party libraries and implemented in Java. So definitely take a look at how that works. Default and static interface methods appeared, and I mean, right now I can't imagine how you could live without them. Before, apparently you could. So there's that. Optional class is definitely something that helps you write code without any if statements if you feel like having that challenge. And if you want to try that, I definitely would recommend playing around with that. Collections API improvements for each split iterator, replace all, calculate, merge methods, etc. appeared. Java I/O enhancements, right? Some easier ways to open the files, form the path to the files, etc. A bunch of other improvements for APIs like concurrency, JDBC, encoding, and so on. But as I said, the list is long, full of terrors. Feel free to browse Oracle website. It definitely gives you the correct corporate smell if you feel like having it. Also, Java 8, for better or worse, was the one that was the baseline for Android development, right? When the Android as a whole kick-started and became a big thing, right? Since Android Studio for the 2 can also do that with Java 11 features. Nice thing to have. And I haven't seen yet any idea to migrate to the next LTS version, which is Java 17, but it's there. Hopefully at some point it will happen. Also, just to kind of nail that thing down, there is no such thing as, like learning Java 12, like learning Java 17, or etc. If you learn Java, I guess the absolute baseline, as I said already, is Java 8. Everything beyond that is an evolution, not a revolution. Java 8, you could consider in certain fashion a revolution, because it really was a huge release with a lot of features and changed a lot how Java works with new features coming over. With that said, why Java 8 is still in the picture, right? So it was released in 2014, that's 8 years ago, right? Why? right? And then there are answers, right? For example, some build tools to this day are just throwing things around while building later Java versions like reflected access and whatnot, right? It's a normal behavior since I don't even know when, but it's still a warning in the compile procedure and it's still there. So there you go, you have it, right? Um, Licensing is also a thing. Until Java 8, there was one GTK provider, one license, everybody was on board. It was by default free, nobody was raising any fuss about it. In 2019, Oracle changed the licensing approach, and like unless you've been living under a rock or have not been into coding at all, there was a huge litigation process in the US about like copywriting and licensing interfaces as such, and so that thing got to the point where there was a lot of uncertain, like unfounded fears that Java will become something that is not free anymore, right? It didn't end with that. It's kind of like Java is still free, you can get it, work with it, it's fine, but the fear is there, and it's kind of hard to beat it in, especially in bigger corporations, right? Also, let's say if you have a legacy system, which is basically only maintenance mode, migration, it's in certain cases definitely involved some work and rework. So that was also pain that companies may choose not to take on, for better or worse, right? So those are the basic reasons, right? And before we continue beyond Java 8, right? And this whole thing is kind of going to be sectioned into two places. So Java 8 world, right, where we talked about reasons for not moving, about what's in there, about versioning, and everything beyond is kind of like once you take the step to Java beyond 8, the upgrade path is kind of built into your progress, and it's something that you gets a lot easier to do, I would say. Step by step, version by version, it's there, right? So, but before we continue, I would like to cover briefly about Java distributions, right? Because I mentioned that with Java 9, there are a lot more new ones, right? So obviously we have OpenGTK, which is the Java source code, right? If you like, this is the where you can like, if you're into Arch Linux, this joke might not be a joke for you, but you can build your own Java, right? I mean, if you're for some reason have to patch on your own branding on the Java, you can do that if you feel like it for whatever reason. It's possible because the OpenGDK source code is available. You can work with it, you can build it, there are instructions, etc. Right? Oracle, as owners of that OpenJDK source code, they provide their own builds, right? The OpenJDK builds are basically something that gets built for every existing latest Java version. So, for example, while Java 16 was the latest, right? You get support for it. Once you reach 17, Java 16 build support is over, and 17 is support, right? Oracle JDK is branded build of OpenJDK with extended support, right? So the idea is that it's free for development, but licensing fees apply when you start working in production. So for certain reasons, you may choose to go with that or not, right? Obviously, there are open alternatives, which was initially called Adopt Open GTK, and right now it's called Doctium. It was started by Java user groups, a bunch of vendors, developers, and fans who did an open Java implementation, right? It eventually ended up as Adoptium under Eclipse banner. It has free, high-quality, lengthy support. It follows the guidelines of LTS, etc. And the key thing from this is that unless you have really good reasons, this is the version to go with, right? So this is probably the best choice you have if you're doing some kind of like mid to small project and you want something of high quality supported, and probably that's going to be supported in the future as well, right? At the same time, there's a bunch of other providers, and if you open the wiki link that is here, right, and there are a bunch of like Azul Zulu, Amazon Corretto, SAP Machine, everybody like can build their own JVMs, which can or maybe choose not to pass JDK certification. It's open game basically. And really final thing before we continue, because it's also important to understand where we're going to go with the features listed in the next slides. There are incubator features and there are preview features, right? So incubator is, you can think of it like somebody threw several pieces of a possibly final API for you to play around, test, and give feedback about. And you really should not assume this is final, full set, and it's going to work as it is working at the moment. On the other hand, there are preview features, which are basically kind of an introduction of what is going to come to Java, right? So you can familiarize yourself with that. For example, people who are doing tools for Java can work with those preview features to get their tooling working properly. And you can, if something is breaking, you can plan for that break and you can see it like a year or half a year in advance to see what's coming, right? So two distinct things. Incubator may or may not happen, definitely going to be in the pieces, might appear, disappear, no guarantees, but you can give your feedback and influence how it's going to end up working in the end. And preview is something that is a lot closer to final and is meant to introduce it to you as a developer of how it's going to work, right? So moving on, Java 9, right? So let's see what we have here. Again, improvement to collections APIs, like as they call it, cheat mode for creating lists, sets, maps. I pick things, I use them, abuse them, unless you want to have something which is mutable, because these methods create immutable entities, immutable objects. So tough luck, right? We also have streaming API, take while, drop while, and I mean, if you have used them, and you are still on Java 8, I salute you, because I tried implementing them myself. Pain in the ass. Libraries at that time were also kind of complicated to work with these methods and this kind of approach. So this is a really welcome API. I actually did the one homework at that time, and I really wanted these methods, and it was really hard to do them on my own. So I'm happy to see them come about. We also have optionals, right? So improvements, if present or else. I think that you can, like, as I remember, I said that you can use optionals to avoid writing ifs. There's your tool, right? Interface got private methods. So before, you remember, we had static methods and default methods. Now we have private methods. Diamond operators got extensions. I didn't choose to include examples for those because they usually tend to become big and it's hard to explain how that happened, right? JShell, right? So you can run a shell, right, and execute Java statements. Finally, something that a step closer to scripting, something that JavaScript already had and other languages had. Java's on board as well. HTTP client, right? It's a preview version for now, but you can already feel that it's coming. Jigsaw module system, I chose, again, it's a big topic of how to use it, but it's basically a tool to make your code more isolated and to kind of modularize your big applications, right? So you kind of, a module gives you ability to define better your external APIs that you provide and prohibit other users from extending your internal classes, even though they're public by definition, right? And Unicode 8 support, so it's there, right? Moving on to Java 10 then. It's a relatively small release, right? It's, again, this is like where Java is warming up to these like 6-month release cycles. So not that much features for day-to-day developers. There have some been under the hood. I'm not even going to go there. If you feel like looking up something, be my guest, right? But what you have to know is that there have been improvements to garbage collectors, because that was a bit of a performance pain for a while. And we also have kind of variables without any type, right? So you can see an example below. And the idea of this is like, it doesn't give you much freedom, even though it looks like this, right? But still keeps the strong types, can rely on that. But the idea is to kind of like move away from the definition of variable, which kind of repeats. It's an optional, then it's an optional, blah, 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 and just focus. I'm saying this is my variable, and a function on the right-hand side might imply what kind of variable that will be. The onus is on the initialization as opposed to on declaration, right? So your initialization part on the right will tell you what kind of variable that will be. Okay, moving on. Java 11, next long-term support version, which will have longer support than usual, right? Relatively small, right? Some things went out of preview. Some strings, for example, in files got really kind of nice features where you can cheat and do things simpler. For example, before, checking if a string was blank was not that trivial because, I mean, some special symbols might have been there, etc. So now you have out-of-the-box functions, right? Same with lines, meaning that /m got separated into lines. Stripping of spaces around, stuff like that. Not big ones, life improvements. I think that's a good direction to go because life improvements is something that you want to see in the end. Ability to run source files directly from Java command line, right? So JavaScript is notoriously known for that, meaning that you can run JavaScript and it will do things just because it's JavaScript, right? So now you can do that with Java. It's just basically you have to have that main method inside of Java class, etc. But it lets you run it without compilation just like that. So if you feel like grabbing something and doing some sort of a script, it's thing you can do with Java 11. Local variable type in inference. So that's again a var. It becomes not a preview feature but in Lambda parameters, right? So before you always had to define those types. Now it kind of works with var, and you can roll with that. Final form of HTTP client. So there are probably bigger, better web servers that you can use, but HTTP client is something that you can just have up and running without too much dependencies. It's up there if you feel like using it. Some other stuff which are a bit like more niche, flight recorder. And the thing you need to know about it is that this is a previously paid for profiling tool for tuning your Java application performance. It went out open source and is something that you can use nicely and work with, right? No operation garbage collector sounds a bit scary, but this is basically like a way for you to turn off garbage collection. And there are use cases where you might want that. For example, if you're building a rocket and you're building a kind of navigation system, right? And that rocket at the end of the day is going to explode and it's going to be an ultimate garbage collection, right? But until you fly, you literally prefer performance above garbage collection, and then you just choose to use no operation garbage collection, right? So that's nice. Right, moving on to Java 12. Unicode 11 support, right? There's like a bunch of small changes, but this one was a bit more interesting. And if you follow this line really carefully and look at the very right corner, you will see a bunch of emojis. And that list is definitely not final. I mean, it's actually a lot longer, right? But Unicode 11 brings along a bunch of emojis support. And this is where I'm going to tell us a brief story because the slide doesn't contain much else beyond that. And I was working in a bank and we actually had a significant production issue because at some point in time, Apple devices started replacing smileys like 2 dots and a bracket into a smiley emoji, which ended up breaking the system because that backend was Java and Java was not able to handle that text Unicode of emoji, right? Kind of sounds simple, but actually broke down production for a brief while. So there's that. Also, there's a preview of our switch statement, but we'll cover that in its later form in the next slide. So let's move on to that. Switch statement had a lot of flack before because it was really ugly. It always required the break command, etc. And that was not a nice thing to work with, because if you, for example, forget this second break, your end result, even if the option was A, will still be false in this statement, and that sucked, right? So this whole long line thing gets replaced into really, really nice, small, concise way of handling things. And if you if you're not using that, you do something wrong, and you should definitely try that. One thing I've noticed here, like I'm using IntelliJ Community Edition, and if you write something like this, it like highlights with a yellow ugly color and said like, do you really want to keep this? Because if you click on it and there's this light bulb symbol nearby, it will suggest to you to replace into this nice concise way. And I suggest, like, in general, let your IDE help you. Like if you see something yellow like this, definitely try checking what your IDE is suggesting to you, because sometimes it really helps you to write a lot cleaner, smaller, nicer code. And one of my absolute favorite features in the newer Java versions is the multi-line string. And I have no idea how Java could live this long without it, but it's here, right? So if you, for example, writing in SQL queries, or some kind of longer JSON for whatever reason in test, for example, something like that. The beforehand, if you wanted to line the multiple lines, you had to do this plus, 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 blah, blah. And if you forgot, need to copy paste this to an actual SQL client and test how this query works, holy hell, good luck with that. Feel free to replace all the bloody symbols that you don't need. Right now, with this multi-line string, it just works. My personally, one of the favorite features here. So moving on then, Java 14. Switch statements are finalized, right? So they don't differ too much from the initial ones. The one thing of more interest is that you can write in the comma options of that you want this to work with, and they will all kind of work with one statement. So it's kind of looks nice. I really like that feature. It's final with Java 14. Definitely is worth a look. And again, the same yellow thing was saying that my point is a stupid code because it should be replaced by a record. And record is a new concept coming to Java, so it's a immutable way to store data without creating a bunch of setters, getters, and whatnot in the class, right? So there's that. It gives you a built-in comparison, equals, hash functions. Real nice thing to have. Again, key thing here is they are immutable. So keep that in mind. Moving on to Java 14 other features. Oh, this is my probably second best and loved feature, is helpful null pointer exceptions, right? So before, if you had this kind of code, right, it would just say null pointer exception at line blah blah blah. That's it. Goodbye, right? Right now, if you write code like this, it says to you that I cannot read filled eggs because point is null. And how cool is that? I mean, it gives so much more information. I really like that, especially if you have this long chaining thing, which you should not do due to a null pointer safety. But if you have a point dot coordinate dot axis dot value, right, any one of these can be null. So that thing would help you figure out which is actually null at some point. Pattern matching, right? So before pattern matching, you could write like if object is instant of string, then you have to declare it and cast it to a string maybe thing, and it will not throw a bunch of errors at you, and then you can work with it as a string, right? Right now, you can write a shortened version of it, like object instance of string, which is going to be known from now on, maybe string 2, right? And then you can work with it as a string and just go wild, right? Again, really nice, concise way of saying that within a scope of this if, my string value is going to be known as this, and it's definitely string value. Otherwise, we're not going to go into this if statement. Right, moving on then. Some incubator features. As I mentioned, this is a way to package your application. Since starting with Java 14, there's the incubator features which kind of let you package your Java as runnable packages, right? So different ones for different environments. 3 of them supported at the moment. Again, this is incubator, so they're probably definitely going to change, but they're there, right? Further improvements to garbage collection. Again, if you're that deep into Java, feel free to Google because they're getting really esoteric at this point. Moving on to Java 15 then. Multi-line strings are, as I mentioned before, they're preview. Right now they're production ready, final. I'm not even going to report that again. Really my favorite feature. Sealed classes are appearing as a preview. And this is like when you have a class and you really are an evil individual or you have your reasons, you might want not to allow that class to be extended, right? So, and there is a way for that now. You declare it as an abstract sealed class, right? And you say that I permit weird point or another point, another type, another class to extend my shape, right? And then this extends shape and you're good to go, right? You are limiting with Java code at compile time who can extend your class. And that's really nice thing to have if you're writing an AP and kind of a library which might be used without any modules as a dependency. That's when JavaScript engine was removed from Java 11. It's an interesting story how it got here. Probably would take a whole different section to talk about. I'm not going to go deeper into that. Z garbage collector becomes production ready, and I think this is the one which is the concurrent one, so it kind of runs in the background without affecting the current threads which are working their own thing, right? So that's a significant performance improvement in that area too. Oh, and there's the Unicode 13 support, also nice thing to have, even more emojis, right? Let's move on. Pattern matching is marked as production ready. So we talked about pattern matching before already. That it's like if you write an instance off and you get to declare that thing as a variable, you're good to go. Records are also production ready, so you can use them since Java 16. And there's a thing called foreign linker API, which previously you could use native build libraries from Java via GNI. It was exceptionally brittle and complicated to use even with the tooling. And then for Java 16, there comes an API which aims to make that more dependable and easier to work with, because that was really a complicated thing to do. Java 17 comes along right next, and that's a long-term support version, which, like in my case, when I wanted to migrate, I didn't even consider all those minor versions, non-LTS ones. Once LTS hit, a month later, we were on board and our client said, thumbs up, good to go, we're happy, right? And I got my multi-line string feature, which I really, really enjoyed. This pattern matching thing, like we talked about before, it comes into switch statement, right? So for example, like switch now can switch on an object, right? And we can check its case, right? So what kind of type is it? If it's integer, do one thing. If it's string, do another. If it's point, do even a different thing, right? And that gives you a lot of ways to kind of work with different objects coming from factories and whatnot and interact with them differently. And that's really nice and concise way to write that down, right? Sealed classes become production ready. Also, I think if you're that kind of guy and want to write your own API. Foreign function and memory API, that's an incubator thing. It's like it would give you even more access, but since that is a really, really touchy subject and how to work with it and involves a lot of security and whatnot, it's quite far away from being something production ready. This is an incubator feature which can play around. I think people on the Java developers teams would be happy to incorporate your feedback. Java Security Manager, a dinosaur from Java 1.0, is marked as deprecated and will be removed in the future. So if you had something in Java 17 working with Java Security Manager, it's about time to consider like dropping it, really. Java 18 and onwards, so deprecation and of finalization. So finalization was a feature that was allowing you to finalize or free up your object nicely. So the idea was that, for example, if you have a factory which has a bunch of JDBC sessions hanging on it, you can like free them up nicely in a finalized method. Problem was that from security, performance, reliability, and maintenance perspective, that thing was abusable to no ends, and it was really easy to write code which was breaking garbage collection, blocking it, and doing God only knows what. So just even if you're writing something with earlier Java versions, don't use finalize, right? There are other methods. I challenge you to Google them and find them, but finalize is not a good approach, and history has shown that it's meant to be deprecated and basically removed at some point, right? Internet address resolution, like before you had a built-in API doing that, somebody came up with a good idea that might be a good idea to allow third-party resolvers for whatever reasons if you have the need for them. Second preview for pattern matching and switch statements. Again, it's not yet ready to go. It's a preview. Feel free to play around with it. Implementation of core reflections with method handles. And this is diving deep. Like if you want to play with reflection and accessing things in the way they should not be accessing things, you might be interested in that, but probably it's again, quite a niche thing to do. Still there, right? Simple web server, again, a way to kind of have a web server up and running without any third-party applications running. Second, incubation for forward functions and memory APIs, right? So again, as I said, those are the touchy ones which allow you to access CSAN native things, really complicated ones, so it's still in incubation. Vector API for scalar computations, right? So this is I think a kind of a nod to scientific community where that thing actually happens a lot, right? And this roughly what it does, it kind of allows a targeted code to do this in a parallel, a lot more efficient way. Before you could do that, it was not that easy. With this API, it becomes easier. UTF-8 becomes a default encoding for Java APIs, right? So before you had to do some mental and code hoops to get that. Right now, it's a default. Snippet annotation is something that you might want to use in your Java docs for providing the sample code, which would then in Java docs be formatted better and work with better and highlighted and whatnot. Nice thing to have. Again, quality of life improvement, right? Java 19. It's like literally released officially 2 days ago, I think on the 20th. Probably only, I think, OpenJDK right now, but it was like, given that it's like literally a couple of days ago, it was still a bit murky to find the specific information. So please don't judge me if something is wrong here, right? But the main features that come with it is structured concurrency, right? So the ideas of Vector API, they're kind of being applied again, and since concurrency is here to stay, and that's how you do more efficient code, it's here, right? So this particular thing aims at allowing several concurrent operations to work well within a new concept, which is called structured task scope, for example. So if you have several futures, right, which are being spawned via scope context, right? Then the scope will know that basically either I fail both of them or I allow them basically to proceed only if something happens, right? So this is a sample code where that happens. Pattern matching for records, right? So I mean, the fun fact is if you look carefully here, like my IDE, the latest one that I could, is not even recognizing that. It just cries about errors left and right. But the brief idea here is that if I find a record, right, of a certain type, I can take values out of it, and they will be available variables within the scope of that pattern matching block. That's a nice thing to have to simplify the code and remove a bunch of shorter point dot x, shorter point dot y, etc., etc. You just have these as variables of your chosen name, right? Right. So foreign function and memory API is a preview in Java 19 after several versions being an incubator. Virtual threads are also a thing to kind of a nod to multi-threaded environments and how to do that more efficiently. And these are kind of lightweight, not the full threads, but they give almost all the capabilities of a full thread. So, and the idea is that they will work more efficient than full threads because those require more resources. More improvements to pattern matching is switch statement which allows you to kind of do complex object matching. Again, these samples I found were too complicated, so I chose not to include them. If you feel like diving into this, go ahead, be my guest. Vector API incubation continues from Java 16, 17, 18. It's still not done because it's, multi-threading is kind of actually hard to pull off properly. And that's about it. So when it comes to kind of existing Java features, right? So Java future, again, specific commitments are not there yet, but there are proposals, right? And for example, extend local variables, right? So this is a way to share some immutable data among those lightweight threads that we just discussed. Interesting concept because sharing data among threads was definitely a pain at all the times. Value objects, which is a kind of like an object which should not be changed, and that gives you a different ways to compare them, right? But you should not be setting properties for them. Primitive classes, which should be treated as a special kind of value objects as well, come in here. Might come here. Again, everything is up in the air for now. String templates, so if you want to have those things that are available in probably a bunch of different libraries already. Sequenced collections, again, this is a way to handle a big collections in a more structured way for potential gains in performance due to being able to parallelize that computations. Profiling improvements so that you can get better understanding of how your Java works and where the performance bottlenecks are. JDK source structure improvements. This is basically a review of how and where and what code is stored so that it kind of is more up to speed because there is definitely a lot of legacy things there, at least from what I read. And class file API, this is again for something to work with classes and instancing of them via reflection, if I'm not mistaken. Again, proposals and potential things to be there might happen, might not. And if you want to know more, basically how Java those proposals are handled, how the process looks like, etc., there's a nice article that I have here linked, and probably if we can attach this presentation somewhere to this video, it would be probably useful to, if you want to go there and look through. It's a good material. I enjoyed reading to that article. I hope you will too. Also, what it does, it also gives a bunch more links to where you can look at the details and maybe even get involved if you feel like diving deep into Java, right? And question, oh no, not a question, like this is a question from me to you, right? So I remember at the very start, I asked you to kind of count the emojis, right? So probably we don't have a chat working nicely, right? But just in your head, like, so how many improvements related to emojis were there, right? Because I counted 4, which are listed as major improvements in different Java versions. And I mean, it's a thing, right? And which that we actually move to a question that or questions that you may or may not have. So feel free to drop any in the chat if there are any. If not, then I will be free to let you and everyone else go.
Yeah, thank you for your presentation. We have some questions in our chat. Let's start with block of questions about the GDK. So first question is, what is the reason to create your own build of GDK?
Oh, as I said, like if your company for whatever reasons feels like slapping on a support license agreement and some branding that you have, I mean, go ahead. Why not? Frankly, from my point of view, it's a pain in the head, right? You should not do that. but sometimes people chose to.
Okay, thank you. Yeah, next question is what is the reason for Amazon, SAP, JetBrains, and other to build their own GDK builds?
Well, if you're Amazon, right, and you have like literally huge farms of machines running things, right, and I assume a bunch of those machines run Java, right, and you're a big company who has a lot of resources, and you literally can save money on, custom garbage collection because it decreases the amount of resources you use by 3%, right? And let's assume your electricity cost is $1 billion. 3% of $1 billion is shit. What is it? It's like 3 million, right? I would get a team of Java developers working on that single improvement in no time, right? And if I can think of these kinds of improvements left and right and a bit more, I mean, it's just literally money saving. Again, licensing things, right? If you are as a vendor just supply certain applications to your clients, and you want to kind of ensure stability, offer your own support for Java and whatnot, this is the way to go. This is why people chose to have your own builds. So, I mean, if you're big enough and you need to, go.
Okay, next question is about Java 9. Please tell about your experience in using modulus feature in real projects.
Oh, Java 9. I actually haven't had that experience personally. I have read articles about how and where they're meant to be used, but it does like fundamentally it doesn't differ a lot from any programming language. Like the idea of a module is that you encapsulate certain features, and you're telling external users that, well, yes, this class may be public in my library, right? You should not be using that because you will not be able to do that successfully, or there are other reasons why that is so, right? So if you do a module, you have means to say that this is the limitation. This is like me as a module provider. I give you these APIs and you should be using them. You should not be diving deeper and figuring out how that black box works. You should be happy with what you have. If you're not happy, feel free to open that other repository, have all the unit tests, have all the documentation and whatnot, etc. in there, and then you might understand why that is working so or in the other way. But this is basically about setting boundaries, right? And exactly the same behavior is in JavaScript, TypeScript. Exactly the same behavior is another language which work with modules. Nothing different this year. It's just a way to kind of make your application building blocks kind of limited in what you can do with them. And that's a good thing because that's how you do a resilient applications where you can replace a certain module with the other without bothering about internal implementation, right? At some point, you might choose to replace database access module with something that is native, right? Via some native API, as long as you have a well-defined interface. So I hope that answers the question.
Yeah, I think that answers the question. Thank you. And yeah, two more questions, more practical ones. I say, what is better to use for singletons? Collection dot singleton list and objects, or list of objects? And what do you prefer and why?
Well, okay, so it will come from the fact that what is a singleton? A singleton is basically a concept of an object that is only one within the whole system, right? So let's say if we're talking about days of a week, right? Then I would challenge you to find a reason to have more than 7 or less than 7. So you could consider a list of weekdays to be a singleton, right? But when you talk about a immutable list, and I assume it's like, then that's list off, right? And I'm not sure. I think that you probably can change values of a singleton list in a certain way because it's one, right? So anybody who's trying to access that list would then be blocked by you changing, and everyone would have those values. But again, I am not sure if that's possible. I would need to look deeper. But I mean, okay, so fundamentally, singleton is something that you will have only one across the system, right? So there's probably no way to clone it, no way to like create a new copy of it, etc. And a list you probably can clone, probably can copy if you feel like it, but it's still going to be immutable. So I cannot answer that question. That's a bit deeper than I can I'll pull out of my head. If you post that in the chat, I will definitely look it up and try to answer you later on in the Slack that we have. Okay.
Okay, we will send you this question. Yeah, and the last one is: do you use var keyword in your projects?
Oh yeah, I actually did. And it was in a couple of tests, right, where the name of the variable is a lot more interesting than literally half of a screen where the multiple diamond declaration was present, right? So it's like, you know, optional, of list, of hash map, of some factory, which is doing something for an object, which is handling transactions, right? So you have like 5 deep diamond function as a, you know, as a declaration, which basically hides one name, which is, you know, like test object, right? So what you do is like you write var test object, and then you do some initialization, which does all the heavy lifting and all the long lines and whatnot. Just, you know, come up with a good name, which tells you that this is my test object that I use. So I mean, it's not a key feature to use. It's something to use in your code when you want it to be focused on initialization on the right-hand side, as opposed to declaration of type on the left-hand side. So that's, I guess.
Yeah, I personally agree. Because you know, when I read this question, I remembered the joke about Java engineers who need very wide screen to see the class name.
I mean, if you don't have a 4K monitor at work and you're doing Java, you're doing something wrong. There's that.
There is one more question posted. I'll publish it. What is the difference between list of and collections empty list?
I don't know. Like, I'm pretty sure that one of them is actually calling the other underneath, but I don't know exactly. Knowing Java engineers, I think probably list off is calling collections empty list, but I'm not sure. Because list off came later than the bunch of collection API, like APIs. But again, I don't know which came first. I'm pretty sure that underneath they're doing the same thing, and you know, dry principle and all that. Don't repeat yourself. So one of them should be calling the other. You know, being fair, you know. So
okay, yeah. Let's look at it after the meeting.
Yeah.
I think that's all for today's questions. If
Before
no one,
these questions actually about lists, like if you will have a fast talk about collections, and if you didn't have one, we should probably arrange one. Those are good places to ask these, because the person who is going to do that presentation should know the good answers, as opposed to all these fishy ones that I gave. So
yeah, I suppose we have such a light talk in our plan.
Cool. Okay.
Okay. No questions left, so I suggest we end this call. Thank you for your presentation again, and thank you everyone who joined.
Thank you, everyone, and have a nice day. Goodbye.
Yeah, bye.